there, and welcome to the Data Platform Summit for 2021, presented to you virtually and pre-recorded. My name is Charley Hanania, and it's wonderful to be here speaking to you all from Zurich, Switzerland. Now, what I'll be talking to you about today is basically the concept around a lot of confusion that's going around and a lot of the options that are available to us from on-premises into the cloud. So I'll be talking about some of these viable options when you're considering on-premises SQL Server to the Azure Cloud for Data Platform. Now let me tell you a little bit about myself. My name is Charley Hanania. I run a company called QS2, Quality Software Solutions, out of Switzerland. And basically myself and my colleagues within the company, we are consultants going around to different organizations, helping them on their Azure journey, as well as looking at a lot of their on-premises systems for optimization, data warehousing, configuring systems, application development, you name it. When it comes to data, that's the sort of stuff that we're working on. I'm a Data Platform MVP, as it shows on the slide here, and I've got a number of certifications, and I'm also a Microsoft certified trainer. Now, what's the reason? Let's go over it again. What's the reason for this session? Now, a lot of you here are using SQL Server on premises, and as a result, you're familiar with the relational database technologies, SQL Server, Power BI or SQL Server Reporting Services, SSIS, etc. But these things are running in the context of on-premises. So a lot of developed standards and procedures would have been created for you to be running efficiently and proficiently within the on-premises environment. But now there's a new player in the mix. Now we're looking at either hybrid solutions with Azure coming into play or Azure-only type solutions now that people are looking at moving their whole data centers into the cloud. So what's the right way to do this? What have I seen with some of the customers, and how do we find better ways of working through some of these circumstances? Now, we'll be presenting this over the next 55 minutes or so. This is a pre-recorded session, and I'll be available online basically as the session is going to answer questions, to follow up on any ideas or concerns that you might have. And hopefully after the session as well, I'll be online so that you can also ask some more questions or follow-ups as we go forward. So let's take a look at what we're talking about when we're talking about on-premises SQL Server. So we're talking about the database engine, right? SQL Server, instances, possibly multiple instances that are going on there, or multiple servers that are installed, probably virtual machines, with lots of standards and procedures around backup, restore, and that sort of thing, availability as well. We're talking about SQL Server integration services, analysis services, reporting services, as well as Power BI on premises. And as well, we'll be touching on machine learning services and master data services, which are available within the SQL Server boxed product. When we're talking about this as well, so if you're using the SQL Server relational database, we're talking about OLTP systems, transactional systems, or decision support systems or reporting systems, as well as maybe even data warehousing, because over the years, SQL Server has developed and improved in so many areas so that SQL Server can be the go-to product for a lot of these areas. But what I've seen a lot of within the organizations that we work with is that there's something that is referred to as server sprawl. Okay, so either physical servers or virtual machines that are created with bespoke singleton databases out there per instance. Now, with a lot of our customers, we work very hard to sell the concept of using consolidation as one of the key areas, because that saves on maintenance, it saves on patching, it reduces your attack surface when it comes to security and best practices. Patching doesn't have to go along to a whole number of systems and so forth. And it also means that when you're managing things in a central way, you can develop standards and processes and procedures to maintain high availability, disaster recovery, performance, and these sorts of things. Now, SQL Server within its product for the relational database has so many features and capabilities to be able to work in this sort of a way. So from securing your environment to improving performance, a lot of the things are within the relational database box product. So now that we've spent a lot of years developing those areas, there is a concern with a lot of DBAs and a lot of IT professionals as well who are working as admins. What happens to our skills now if we're going to be going to the cloud? So we're going to be talking a little bit more about those concepts and where to go and how, in my view, things only get better now that we're looking at the cloud, not only as virtual machines or physical servers on premise. The next thing we're going to be looking at is integration services. Now, a lot of you know, integration services is the key way to perform extract, transform, and load processes. Okay, this is the way that we integrate, that's why it's called integration services. We integrate data between databases or between servers, or we have good ways to export data and to qualify data and also bring soft data into things like SQL Server analysis services and things like that. It also has some very powerful data quality and cleansing capabilities. That's part of the transformations capabilities that are built in to integration services. And because it also is quite a mature technology, a lot of these procedures have been developed and built upon over the years through the on-premises box product. Next, we're going to be looking at analysis services. Okay, analysis services comes in two forms these days, multidimensional and tabular. They can be installed on the same machine as different instances, and basically they serve the purpose of aggregating and analyzing data, as well as doing some predictive analytics as well within there as well. So that allows a lot of organizations to say, how are we going year on year? If I wanted information to report off with all of the different entities and so forth, I would use analysis services because it's pre-aggregated and perfect for reporting on large data sets. Next, take a look at reporting services and Power BI on premises. So these two products, okay, over the years have been developed into what's called Power BI Report Server. And these allow you basically to report off the data that you've got within your online transaction processing systems as a decision and support or reporting capability. Power BI is a dashboarding and has a lot of functionality that's been built into it over the last couple of years, and it allows you to also report off very large data sets. SQL Server reporting services is more for static reports and what we call paginated reports. And they can be embedded in your applications. You can provide subscriptions on top of them to say, hey, every morning I want this report to be published and then available and accessible by different groups. Overall, they're great to be used together with the SQL Server product, and we've found over the years many different ways for DBAs to bypass the capability of saying, well, I'm not a developer, how do I work with the data that I've got? We've found a lot of bespoke solutions being developed within reporting services so that DBAs and IT professionals who don't have coding skills can actually change data and develop sort of functionality within their database applications by using reporting services. And then the last two things I want to talk about are machine learning services and data quality and master data services. With over the past 2 or 3 versions of SQL Server, machine learning has become an item, okay? And bringing machine learning closer to the data has been something that has really changed the game when it comes to SQL Server and data in general. A lot of data science programs say, well, we don't have very good procedures. It's a very science type situation where we haven't got standards and procedures and security and these sorts of things around how to use predictive analytics when we're close to our data. So Microsoft brought out SQL Server machine learning services to be able to run machine learning models closer to the data without having to go out of box or out of server to be able to do that sort of thing. It allows you then to bring in some procedures and processes to really qualify and maintain and develop the models that you've got, as well as bringing in, using T-SQL, the predictive capabilities that come with machine learning models into your applications. So using T-SQL, you can use a predict function to say, well, given this data set and this model, what can I predict as being the best value? And that way you can develop lots of different types of scenarios and situations within your applications as well. The last one that we want to talk about is master data services. Now, master data services is the capability to bring governance into your entities that are shared across your enterprise. These can be seen usually as reference data within applications, but not always. So there are a number of different things that you want to be able to report against within your organization, and you want to make sure that, hey, we're not taking lots of copies of this within each database or within each application. We want to be able to refer to these centrally and to have data stewards who are responsible for attributes within these entities. Some of these might be, for example, customers. So you want to make sure that your sales and marketing and internal accounting teams refer to the customer in the same way. And when you're trying to make a sale, that the invoice that gets correlated to it is the same, and that you know that when you're sending out a lead, that you're actually able to report against them and invoice against them correctly. So this way you give accountability and you have processes and procedures around it to say, hey, these entities are going to be managed in a certain way. If a change to an address or an email address happens, that it needs to be approved and then qualified, and then it can slip into all of your application systems at the same time because of the way that this data is centrally managed. It allows you also to make sure that there's data quality through some of the processes and procedures, not only through integration services, which we sometimes talk about, but also through master data services to say, hey, a postcode has to be in this format, a telephone number should be in that format, reject it if it's not, or flag it for follow-up by whoever is responsible if it doesn't meet those governance rules. So they're the main products that we'll be going to be talking about, transitioning over to the Azure equivalents. All right, so let's take a look at how that might work. So on the left, we've got the ones that were on premises, as indicated by the buildings on the left there. And on the right, we've got some of the services that are available in Azure, which could qualify to be hosted. Now, why? Because it's very easy to lift and shift these applications and these virtual machines and put them into the cloud. And that is a major approach used by a lot of organizations, and also it's something that is, let's say, encouraged by Microsoft as well for the ease of getting things into the cloud. And for me, that is an edge scenario which has become the predominant scenario, and not for the right reasons. The edge scenario is basically that, hey, we're on the east coast of the US, we're prone to hurricane season and flooding and all these sort of issues, and we're in a data center, and we want to make sure that we can lift and shift our workloads into the cloud with just a couple of days or a couple of weeks notice, so that we can maintain operations during problematic times. That lift and shift scenario has become the predominant method, as I mentioned before. But for me, this should be the backstop. This should be the only reason we should consider that should be when things aren't working the way we planned and we haven't really planned for it. Whenever we're going through a decision to go to a new platform, moving out of a data center or improving our operations, consolidating our hardware or our databases, we should always look at, hey, given that we're making a change, what's the best approach to making that change? Given that there is a change to be made, that we take that opportunity to really leverage the concept of making improvements for the design that we're doing. I'll give you an example. Basically, in the mid-2000s, yes, I'm showing my age, in the mid-2000s, when virtualization became a thing and people were shifting from physical hardware to virtual hardware, the thing that came down from the CIOs was, hey, everything needs to be consolidated. And why? Because Gartner said it was good, Forrester said it was good, the industry was saying it was the right thing to do, so let's do it. So within the organization that I was working with, we got a mandate basically to say anything that is under 10 to 15% CPU utilization should be flagged immediately for putting into a virtual machine. When that occurred, luckily I was responsible for identifying the engineering standards that needed to go through as someone who was responsible for operations. We said, well, no, that doesn't exactly work for us because we're not web servers, we're not application servers, we're dealing with data. CPU was never the bottleneck. So in so doing, we're able to put additional standards in place to say, well, when we're considering moving to a virtualization platform, we have to consider some other things. What are the performance baselines that we're expecting? What are the what latencies and so forth? How are we affected when we go towards this new platform? And in so doing, basically, we're able to circumvent a lot of production issues as a result, because had we just said, well, let's lift and shift our workloads into virtual machine or virtualization environments, we would have found that, hey, all the old standards that we were using before would have had to have applied to the virtualization environment. And this is what we find ourselves in on premises. Even if you run with a very regimented and strict set of frameworks on premises, you might find that just lifting and shifting those things into the cloud end up causing you issues. The example being, in the cloud, you're paying for capacity and usage, okay, with a pay-as-you-go type approach. Even if you prepay or you go for the 3-year subscription options, you're still paying a certain rate, okay, at a discounted rate, albeit. But on premises, what you generally find, or what we generally find, is that we buy capacity up front. We say, okay, look, we've got a data platform ecosystem going on, so we're going to buy this sort of storage, which has this sort of throughput and IOPS. We're going to be buying this brand of hardware with this type of memory, etc., etc. And then what we end up doing is we start to fill that up over a number of years. And then we say, oh, we've filled it up, no problems. Let's buy some more capacity, let's buy some more hardware, and we just continue down that route. That doesn't work, so to speak, in the cloud. You end up finding that with a lift and shift scenario, you're paying for all of the old methodologies. So the standard way is to say, well, what virtual machine are you running? For database servers, usually they're quite large. Great, that's this class of virtual machine, and this amount of RAM, this number of CPUs, this type of storage. Great, so you're paying this amount per month. Okay, if we start doing it that way, then we're going to find that the customer, or we, are paying through the teeth, so to speak, and there's a lot of cleanup that is necessary afterwards once the organization starts to see how much they're paying month to month. Okay, so rather than being on the back foot from that perspective with the organization, with Microsoft, as the licensing tee-ups start to come to play and the costings start to explode, it's better to say, well, these are the workloads that are identified. How can we optimize those beforehand? How can we make them closer to cloud native so that we reduce the operating overhead and the cost, and also increase the maintainability of these systems as we go forward? So let's take a look at what some of these are when we're talking about the platform. And I'll quickly go through the list of these from columns, okay? So the first column there on the left, which is this one here, okay, is basically the relational database technologies that are available. Sorry. The second one there are equivalent to the SSIS or the ETL type processes. The third one there, sitting with 3 boxes in a triangle, is basically analysis services. And then we've got reporting with Power BI, machine learning, and data quality servers and master data management. In the green box there, which hopefully we'll have enough time to go through, are some of the other services that we need to consider, which can be leveraged, which are cloud-based, which can help to reduce the contention and improve the performance and scalability of your data-focused applications, no matter what type they might be. There are different options available to us. So if we get time, we'll definitely want to go through those, and they should give you some more insights and ideas for how your on-premises applications and database servers can then be ready for a cloud-type infrastructure. So let's take a look at the first set. Okay, the first one we're talking about are relational databases. And I think this isn't working anymore. All right, so with relational databases, we have as options within the cloud, we've got the Azure SQL Database family of products. We've got Azure SQL Managed Instance, SQL Server on Azure Virtual Machines, and another relational product but more focused on data warehousing, Azure Synapse Analytics. Let's talk a bit more about Azure SQL Database. Azure SQL Database is what we call a platform as a service offering. There are three types, in case you don't know. There's infrastructure as a service, which is basically the lift and shift scenario, which is the virtual machine that you can actually bring into play and install whatever you like on top of it and run it pretty much the same way you would run a virtual machine on premises. You've got platform as a service, where Microsoft then takes care of the underlying subsystem, and what you need to take care of is the service itself. So in this case, the database service. Okay, it's available in terms of Azure SQL Database as a singleton contained database. What that means, on premises you might recall the concept of contained databases, where the login basically is made available in the database itself. You don't need a login in the instance. This capability then means that you can actually take a database and either use it for availability across several instances within your organization on premises. But in this case, what it is, it's a very simplistic approach and a very good approach for new modernized applications. Could be a web service or a web application, for example, where you don't need to really share that data outside of the container of the database. For resources and cost effectiveness, you can put these databases, these singleton databases, into an elastic pool. These elastic pools then allow you to say, well, I want to manage my workloads for costing, and sometimes I've got peaks and sometimes troughs in my performance within the different databases. In the morning, I've got high activity on this database, and then around midday, I've got high activity on this database. When we level both of them up, they use a certain amount of resources. So when they level up around each other, then you're actually not paying too much per database. So that's the elastic pool concept. Now, how do we talk about these things? Now, if you are looking at this, you're looking at applications which are generally looking within the application database scope. Okay, that means you can use functions such as in-memory LTP. You can still use security features such as data masking and encryption. It's still got all of the same indexing options that you use on premises, including stuff like column store compression and column store indexes, and you can compress them in the same way. Okay, page, row, column store, etc. So all of the features that are within there are generally available, and if you look at the link up the top right there, if you click on that, you'll be able to see the compatibility list of what has changed from on-premises into the cloud. Okay, from the Azure SQL Database perspective. How do you get these? Basically, how can you pay for them within the cloud? Well, you've got two different options here. They are the provisioned type, which is using they're all provisioned, but using vCores or using DTU purchasing. So vCores is where you're basically saying, I want this number of cores, this amount of memory, and so forth. And you generally can determine that because you're more used to how that works on premises. Or you can say, I want to run with the database transaction unit purchase model, which basically says I want this amount of throughput, at least within my application databases. There is another option available, which is called hyperscale. Now, hyperscale is a cloud-ready or a cloud-native approach where we've basically disconnected storage and compute so that then they can scale independently of each other. And that way you can rapidly scale up and out as needed, and you can use functions and capabilities within hyperscale to manage your workloads. And this one's been created, well, hyperscale was created to be able to manage the very large or very performance sensitive databases that you might have, because it can scale up to 100 terabytes in size at the moment, and we expect that as time progresses that increases as well, because the Azure SQL Database model can only go up to 4 terabytes in size. Now, the only thing to take care of here is that if you move a database into hyperscale, currently it's not supported to move it back out into a different type. Okay, so you'd have to be scripting the database and actually putting it again into a different one, so Azure SQL Database or Azure SQL Managed Instance. It's available also in the third type, which is called serverless, which basically allows you to only use what you need at the time, and it can actually spin up and spin down as necessary. It can run something called auto pause and auto scale, so that when it finds that you're hitting a certain threshold, it'll increase the compute power that you might need, and when it finds that you've got a certain amount of inactivity, it actually winds things down and you're only then paying for the storage that you're using. So these are the options between this singleton contained database concept called Azure SQL Database, okay, and Elastic Pools. Within relational databases, we've also got another one. This is the one that has been created because of a lot of response from the community, including ourselves, where we said, well, you're not making it very easy for us, Microsoft, to actually transition people from on-premises into the cloud without the virtual machines. And this basically is the capability of having a managed instance, i.e. an instance that is managed by Microsoft, so that you don't need to worry about the subsystem that is underlying it. Okay, so this is also another platform as a service offering. It's versionless, which means that it's always up to date and Microsoft takes care of those versions. And basically it allows you to run similar to how we would work on a consolidated model on premises. So all these singleton instances that are out there for applications, we say, no, we're going to put them in to a consolidated database server where you can have hundreds of databases as necessary, and you can manage those using best of breed type of concepts and frameworks to make sure that you don't have any noisy neighbors. You can implement standards. You can start to guarantee things such as the recoverability metrics and these sorts of things. Okay, so that is the capability of having multiple databases within an instance in the cloud. It gives you the capability to do most of the things that you can do on premises. And we say close parity because that is not full parity. A lot of the things that are deemed on the server, like access to the file system, can't be done within Azure SQL Managed Instance. And in any case, these are sort of the standards that we adopt when we're looking consolidation, because we always say, hey, you shouldn't be accessing the file system if you're running SQL Server in a consolidated environment. You should be using file servers because they're backed up. You can have the right permissioning and so forth on there. If you lose the virtual machine, nothing will happen, and so forth. So that's the sort of standards that we try to take in any case when we're talking about SQL Server on premises in a consolidated environment anyway. And in this case, it's very, very good because of the close parity to be able to move and shift your workloads into this environment. They've got a really good approach in terms of migrating your databases. You can actually do it through backup and restore. And you can also synchronize to databases in the cloud if you want to use always on and extend always on into the cloud from your on-premises, and then use backup and restore from in the cloud into managed instance. So you're not having to worry too much about the methodology of getting your data from on-premises into the cloud for those larger workloads and databases that you might have. The options that are available to us are similar to what's happening with Azure SQL Database. You've got the provisioned approach, and within provisioned, you've got a couple of different options too, which aren't listed here on the slide. You can have something called an instance pool, okay? That's the fourth point there. And the instance pools allow you to basically do something similar to Elastic Pools for Azure SQL Database, where you, instead of having a very large managed instance by default, which is, if you're doing it as a singleton managed instance, that's what happens. You have a very large scoped one. But if you run with an instance pool, you can go as small as 2 vCPUs or 2 vCores as a start, and then grow it as needed. Okay, this isn't available in all regions, just keep that in mind. But in general, Azure SQL Managed Instances are available in most regions that are global. You can actually deploy these with templates, which is wonderful, so that you have the same configuration, the same standards on how you use the data within your subscriptions. And you can say, well, because of residency requirements, I want to deploy one to Germany, another one to Switzerland, where I'm based, one to the US if you don't want to have your data mixed there, and you want to have separation there as well for applications and for other organizational reasons. So this way you can have these deployment models going out there, and you can work quite effectively in that sort of a fashion. The other way as well is using DTU purchasing, and it's similar to what we discussed before. But in general, what we find is that people are going more towards the vCores, because then you can map more in terms of what databases you've got to the applications that are being run on top of them. The other concept that this allows, which you can't get in Azure SQL Database, is the concept of complex databases. They're the databases that are intertwined, where you might do a select from one database to another, or your OLTP database might be referring to data that's in another database as well. The next one we are going to highlight is, okay, that's better, SQL Server on Azure VMs. Now this is that infrastructure as a service offering, similar to lift and shift, but it doesn't have to be lift and shift. You can say, similar to when we're on premises and we're building in a new server or migrating onto a new version of SQL Server, hey, I want to build this clean, I want to build it with the right standards, with the right operating system. You can do that with one of the VMs that are in the marketplace in Azure by saying, hey, the VM that I want is going to be Windows 2019 with SQL Server 2019, or Windows 2016 with SQL Server 2016 or 2019, etc., etc. So a lot of those are available, pre-created for you or templated within Azure. Or you can say, no, give me a virtual machine to the specs that I want, and I'm going to install SQL Server on there, either for Windows or for Linux or whatever it might be. This gives you a lot of flexibility, although it keeps you then thinking in the old ways. You can have scale, you can scale your virtual machines as you need to, but again, you're working within the same familiarity that you were working with on premises, either with physical hardware or virtual machines there as well. So this way, if you're happier to use those same services, if you want to have multiple services installed on your virtual machine, you can still do that. You can have a SQL Server with a relational database engine with SSIS and SSAS on there to maybe reduce the amount of data movement you've got across the different virtual machines, because you're saying, hey, I want this just to work within the same memory context. Keep in mind though, that because it's on Azure, Microsoft does allow you to do some other virtual machine management capabilities. So that's listed on there as well as one of the points. Microsoft allows the capability to do automated patching by Microsoft, which means that your service packs for SQL Server and for the cumulative updates and these sorts of things, as well as the Windows patching, can actually be maintained by Microsoft with certain hours, and so that you've got the failover groups and all that kind of stuff working together as well. And also your backups can be virtualized, or not virtualized, but maintained by Microsoft. In that case, you say, I want this sort of an SLA, I want to be able to recover it to this point in time, and Microsoft takes care of it in the background. Of course, there are some additional costs involved, but it basically gives you the same capability as what you would have in other PaaS offering or platform as a service offerings, to make sure that you have consistency and the capability to revert back to Microsoft if something needs to be restored. Okay, and there are certain functions within PowerShell, etc., to be able to restore these databases and keep your state happy as well. Keep in mind that because you're working with virtual machines, the DR capabilities are virtual machine focused. So to maintain availability and recoverability, you might have to have another virtual machine in another data center within Azure, and to put SQL Server always on availability groups or failover clusters, etc., to be able to get these things working similar to how you would do it on premises if that's the requirement. Okay, as we said, you can run things as if you're doing it on premises, so that's the capability of installing SSIS, SSRS or Power BI on premises, and SSAS on these virtual machines as well. The last one is this data warehouse or analytics engine type offering. There's a product that was released or rebranded called Azure Synapse Analytics. Azure Synapse Analytics is a data warehouse offering or analytical platform offering. Okay, there are other types within the industry, and this is the one that Microsoft has come up with, and it's based off of PDW and these sorts of things, which is the parallel data warehouse, etc., that actually has evolved or matured into this cloud-based offering itself. It's great, to tell you the truth. It's really, really good in terms of managing your performance, because similar to hyperscale, the compute and the storage are not fully connected. That allows you then to, and it's based off data lake, which allows you then to really get performance gains on both sides as you need it. Okay, you've got two different engines that are available. The relational offering, which is very similar to how we would see SQL Server as a relational database engine, but also Spark is a capability within there too, so that you can use more of the other types of Spark capabilities as well for your very large VLDB or non-relational type of workloads. Okay, Synapse workspaces are something that is part of the backbone of how this thing works. It's your interface into basically how to use Synapse Analytics. You can create notebooks, run T-SQL scripts, create pipelines and transformations, which is similar to what you would do in SSIS or Azure Data Factory in Azure. And allows you to also have Power BI reports and also integrate these things into your DevOps processes so that teams can work within a workspace and produce stuff out of there. It's integrated with things such as machine learning services and Databricks, and there are a lot of first level services within the cloud, which mean that you can actually really expand on your data engineering practice by using Azure Synapse Analytics. So where is this relevant? If you've got a data warehouse running on-premises using SQL Server, and you've got things like clustered column store indexes and these sorts of things to try to, and partitioning, for example, to try to increase the throughput and the performance for your workloads within the data warehouse, this would be a great offering to look into to move or migrate from the on-premises SQL Server into this, and then have very rich and almost seamless capabilities in terms of ingestions and transformations and reporting, and also transitioning data out of your SQL Server, either Azure SQL Database or Managed Instance Database, into the data warehouse concept as well. There are different types. So you've got serverless SQL pools, which is sort of the relational offering, which is similar to serverless that we spoke of in Azure SQL Database. And you can actually have provisioned database, which is a relational database, which uses MPP, or what's called massively parallel processing. And what that does is allow you to really scale and operate effectively across a large number of nodes, separate compute nodes, and really bring data in and out much faster than what you'd be able to do on premises in general. And you've got the serverless SQL pools as well, which, the Spark pools as well, which is basically this Spark offering, which allows you to use a lot of the Spark capabilities, which has a very, very rich and powerful set of tools and language components to be able to do transformations and different type of optimizations within your data warehouse data sets. So that's all we've got for relational databases. Next, we're going to start looking into the next area, which is the extract, transform, and load, or what's also called ELTL capabilities in there as well. So Azure Data Factory is the quasi-replacement or the next modernization phase of SQL Server integration services on premises. It is another PaaS offering, okay, platform as a service offering, and although SQL Server integration services on premise had a lot of functions and capabilities within the product for transformations, ADF, or Azure Data Factory, is mainly an orchestration engine. Okay, that orchestration engine allows you to run lots of first-level integration runtimes, which is either cloud native, like things such as Databricks, or Spark pools or SQL Server pools, etc., or to run some basic functionality in terms of transformations also within Azure Data Factory as well. Dedupe and copy, very fast copy loads, etc., as well. It has some concepts within there similar to what you think about on premises. It's got runtimes. Now these runtimes are listed here. The Azure Runtime are basically the capability of connecting to different services within the cloud, which are native to the cloud. You've got self-hosted, and these are ones that are non-Azure native, but things such as, for example, Snowflake, which if you want to connect to it, you can as a runtime, but basically saying that it's not Azure native, it's sort of an external type of connector, even if it's running within Azure, but not Microsoft native. And then you've got Azure SSIS as a runtime. That allows you to run and run seamlessly your DTS and SSIS packages that you might have had on premises. That way you have a migration approach similar to lift and shift, because a lot of complex business logic is housed within these SSIS packages that we might have had on premises. So you can redeploy those into the cloud and use them within Azure Data Factory within your pipelines that you might have had already running on premises. So this way you can augment the pipelines that you would have already had, adding more functionality, a lot of richness, maybe even allow streaming data to come into your workloads so that you can augment the data transformations and pipelines that you might have internally. Okay, so we have the integration runtimes. We've got linked services, which are the named focused capability of saying, I'm going to use this Databricks session, I'm going to use this Azure SQL Database connection, etc. And then you've got the pipelines, which basically connect the different service orchestration components. You've got activities within those, and you've got data that flows between those components. Okay, and they are called data flows. The data sets that you've got, you can actually have within there so that you can reuse the data sets within several steps or several activities, and also within several pipelines as well. Okay, so Azure Data Factory maps as the modernization concept for SQL Server integration services. Okay, and the concept is extract, load, transform, load, because it's not extract, transform, load, because if you extract it and load it into, for example, data lake or blob storage, you can then bring it in very quickly into Azure and then transform on top of it, and then on top of it, and then load it into the next system going forward. Next one that we're going to look into is Databricks. Okay, Databricks is that Spark type offering. It's also a PaaS service, and there's something called Azure Databricks. So Databricks is a company, and there's an Azure version of it that was created so that it very richly integrates within the products and platforms within Azure itself. Okay, again, it's